Okay, so I think we can start now. First thing we'll do, we'll go over the material from last week. So I'll go over the do now once we go over our exponents lesson from last week. But, okay, wait. Just as a reminder, last week we covered exponents and factoring. So I'll just do a quick review of what we covered in last class. So basically we said that an exponent represents repeated multiplication. So first we define an exponent. So let's say we have something a to the power b. Then this just means a times a times a times a, b times. So all we do is we multiply a by itself, b times. And we have a set of rules for operations on exponents. And we call these exponent rules. So the most important exponent rules are a to the power b times a to the power c is equal to a to the power b plus c. A to the power b divided by a to the power c is equal to a to the power b minus c. A to the power minus b is equal to 1 over a to the b. And lastly, a to the power 1 over b is equal to the bth root of a. So I'll prove the first two of these, which I think I did last week, but I'll just go over it again because it's a really important concept. So rule 1 says that a to the power b times a to the power c is equal to a to the power b plus c. So what we do, we expand the left-hand side. So we know a to the power b is equal to a multiplied by itself b times. So that's equal to a to the power b. And we know that a to the power c is equal to a multiplied by itself c times. So a times a times a, c times. So now we want to multiply these two things together, since we want a to the power b times a to the power c. But if we multiply a to the power b in its expanded form with a to the power c in its expanded form, then we're just multiplying a by itself, b plus c times. So that's basically the same thing as a times a times a times a, b plus c times. And that's just equal to a to the power b plus c, which is what we wanted to prove. And then you could do a similar thing for rule number 2, which is a to the power b over a to the power c is equal to a to the power b minus c. But instead of just multiplying the a's together here, you cancel out the a's in the bottom with the a's in the top. So then I won't go over rule number 2, but I think we had a few questions about negative exponents. So I'll just go over a few examples with that. So firstly, does anyone have any questions on these basic definitions? Okay, so then I'll move on. So basically with negative exponents, this is the only rule you need to remember, which is a to the power minus b is equal to 1 over a to the power b. So this is pretty easy to get confused with a to the power 1 over b is equal to the bth root of a. So note that these two things, they aren't the same. Since over here, we clearly have a to the power minus b, but over here, we have a to the power 1 over b. So for example, let's say we had 5 to the power minus 3. I think this was a homework problem actually. So this would be 1 over 5 to the power 3, which is be 1 times 1 over 125. But then let's say we had 5 to the power 1/3, then that would be the cube root of 5, which you need a calculator to evaluate. So that's the difference between these two rules. So now I think we can go over the homework from last time. So I think you guys had a few questions that you wanted to go over. So I'll just go over those ones. And in case anyone has any specific questions, then they can also type that in the chat. Okay, so first question we had was 2.22c. So let me just write the problem out. Minus 8 to the power times u to the power 4 times 2 u cubed over 4u squared times 6u cubed. So the first thing you want to do here is you want to separate the constants, which are just regular numbers. So you want to separate these from the variables. Okay, so we know that when we're multiplying, we can basically just ignore the parentheses. So let's just do that. So this would be minus 8 times u to the power 4 times 2 u cubed over 4 times u squared times 6 u cubed. And we know that this is equal to minus 16 times u to the power 4 times u to the power 3 over 24 times u squared times u cubed. So we know that u to the power 4 times u to the power 3 will be equal to u to the power 4 plus 3, which is just u to the power 7. And similarly, we know u to the power 2 times u to the power 3 will be u to the power 2 plus 3, which is just u to the power 5. So then we can say this is minus 16 times u to the power 7 over 24 times u to the power 5. And once again, we can separate the constant and the variable. So this would just be minus 16 over 24 times u to the power 7 over u to the power 5. Now we know this part is going to be equal to u to the power 7 minus 5, which is just u squared. And we know that this thing, if we simplify the fraction, it'll just be minus 2/3. So that will be our answer. So does anyone have any questions on this problem? Okay. So if not, we'll move on to the next problem. And that was 2.34, I believe. Oh no, it was 2.27. So now we'll go, okay, I'll actually put the link so you guys can look at the problems on your own. So the next question was about 2.27. So 2.27 wants us to simplify the expression 2 times t squared minus 4t plus 1 minus t times t plus 7. So the first thing we do here is we expand this term and we expand this term. So the first thing we'll do is we'll multiply the 2 by each of the terms in the parentheses. So we do 2 times t squared, 2 times minus 4t, and 2 times 1. So that would be 2 times t squared, 2 times minus 4t, which will be 8t, plus 2 times 1, which is just 2. So that's this first parentheses. And then for the second parentheses, we multiply t by each of the terms inside. So that's just t times t plus t times 7. So t times t is just t squared. And then t times 7 is just 7t. So all we have to do now is simplify this expression. So I think you guys should know how to do this. But all we do is we keep this the same, and then we multiply each of these terms by -1. So this times -1 plus this times -1. So that would be minus t squared minus 7t. And then if you add this, it's just t squared minus 15t plus 2. So yeah, there isn't really much to this problem. All we did here is expand the two expressions independently, and then we carried out the subtraction once we simplified. So does anyone have any questions on this problem? Okay. So then we'll go over these two problems. So 2.34a and 2.34c. So these two problems, they want us to write each of these with a common denominator. So 3x over 5 minus 11 over 40x. And they want us to write this with a common denominator. So first, just as a reminder, let's say we had a over b minus c over d. So if we want to write this with a common denominator, then we'd multiply the top of this. Okay, let me write this bigger. If we had a over b minus c over d, and we wanted to write this with a common denominator, we'd multiply the first fraction by d over d. Since this is just equal to 1, and we'd multiply the second fraction by b over b, since that's also just equal to 1. So this is equal to 1, and this is equal to 1. So it doesn't matter if we multiply it by this, since anything times 1 is just itself. So now we have AD over BD minus CB over DB. And this is just equal to AD minus CB over the common denominator, which is BD. And then if you can simplify this fraction, then you would go ahead and simplify it. So this is exactly what we'll do for this problem. And it's basically the same thing, except that this has variables and this traditionally doesn't. So let's just write this as 3x over 5 minus 11 over 40x. And we'll multiply the first fraction by 40x over 40x. And the second fraction by 5 over 5. This is basically the same thing that we did here, except replacing a with 3x, b with 5, c with 11, and d with 40x. So once you do this, you get 120 times x squared over 200x minus 55 over 200x. Yeah, that's true. You can do that, and that would actually be like a much easier method. But just for like solidity with this method, I'll go over like the harder approach first, I guess. But yeah, if you guys know the trick that Ahana mentioned in the chat, that's actually like a lot easier, and it takes like a lot less time also. So this would be 200x. And notice that this isn't simplified, since the numerator and the denominator, they both have a factor of 5. So we divide both the numerator and denominator by 5, or times 1/5 over 1/5. And we can do this since, once again, 1/5 over 1/5 is equal to 1. And this is just 24 x squared minus 11 over 40x. So this is sort of the hard way to do it, but the easier way would be to notice, well, the easier way is a little bit more number theory involved. I'm not sure if you guys learned this in school, since I don't really remember. But over here, okay, let me just, so let's say we had AB minus CD. So let's call this the easy way. So now let's say that the the LCM of BD, B and D is equal to K. So does everyone remember what LCM is? So can someone, if you remember what it is, can you please type what an LCM is in the chat? Yeah, so LCM is just the least common multiple. And that's basically the smallest number that is a multiple of both B and D. So let's call the LCM here K. So then what you do A over B times K over B on both the numerator and the denominator. So K over B divided by K over B minus C over D times K over D over K over D. So then if you simplify this, this would just be A B times k minus c over d times k all over k. Let me make this smaller. So this is just equal to this. Actually here you should have just multiplied by k on the top and bottom. So once you do that, you should get this. Okay, wait, never mind. Okay, so I actually miswrote this. It should be what I had before. But I think this makes more sense like when you do it with an example instead of just looking at this formula. So I'll just do like this the easy way for this example here. So we had 3x over 5 minus 11 over 40x. So basically the first thing we'd do is find the LCM of 5 and 40x. But the LCM of these two terms is just equal to 40x. Since clearly 5 divides 40x. So basically we don't have to do anything to the second term. All we do is multiply the first term by 8x on the numerator and the denominator. So that this denominator here becomes 40x. And this is just 24x squared minus 11 over 40x. Which gives us the same answer from before, but it was a lot less calculation and a lot less time. So now, I think I'll skip to the the challenge question, since I want to get to the new theory. Okay, so I'll do the first challenge question. So these are kind of unrelated to the lesson, but they're just optional and they're supposed to be like competition questions. So the first question says that the 10-finger calculator company periodically checks random calculators before shipping crates out to customers. On Wednesday, 12 calculators from each of 64 crates of 144 calculators were tested. 2 of the tested calculators were found to be defective. Based on this rate of defect, how many total calculators are expected to be defected? So the information we're given is that 12 calculators from each of 64 crates of 144 calculators are expected to be defective, are defective, I think. Oh wait, are tested. So we tested 12. So out of the 64 crates, let's choose one crate to look at in specific. So let's call this crate 1. So we know crate 1 has 144 total calculators. And out of this, we tested 12. So we tested 12 out of 144 of the total calculators. Now out of those tested, 2 of them were found to be defective. Okay, so I think this question is a little confusing since it doesn't tell us whether this is like in total or per crate. So let's just assume that in total, 2 tested calculators were found to be defective. So if we test 12 calculators from each of 64 crates, then we'll just have 64 times 12 total tested. So all we did here is we know that for each crate, 12 calculators are tested. So if we have 64 crates, then a total of 64 times 12 calculators will be tested. Now out of this 64 times 12 calculators, 2 are bad, or 2 are defective. So that means a total of our tested calculator population, 2 out of 64 times 12 calculators are defective. So this is the ratio or percent of defective calculators. But the problem asks us for how many total calculators are expected to be defective. So the thing to note here is that there are actually 144 calculators per bin, but we chose to test only 12 of them. So that means if we tested 12 calculators, then we have 12 times 12 equals to 144 total. Or you can say that since this is the ratio of the number of defective calculators, we can just multiply this by the total number of calculators, which will be 64 times 144. So this can be a little confusing, but all we did here is note the ratio of defective calculators, which is this. And this ratio, it's going to be constant no matter what the total number of calculators is. So that's why we just multiplied by the total number of calculators. So now you just cancel out the 64. 12 divided by 144 is 12. And this is just 24. So yeah, I don't think this was a very difficult question, but understanding and like writing down the information that you need is probably the most difficult part of this problem. So does anyone have any questions on the challenge problem? Okay, so if not, let's go on to our new lesson. So for today, I had planned multivariable or one variable and multivariable expressions. So this is a really key concept in competitions, and usually you aren't just given a one variable equation and asked to solve for the variable, but rather you're given a word problem, and then you have to come up with the equation on your own. So there isn't really much theory to this. It's just knowing how to make the equation on your own. So let's do 3.24 first. So the problem says Joanne can't quite read the board in her math class. She writes down the equation she reads on the board as 3x minus 7 equals to 38. So we're told that Joanne copies down the equation 3x minus 7 is equal to 38. She correctly solves the equation she wrote down, but is surprised to hear the teacher say the answer is 6 less than the answer she found. So first thing we should do is solve for x here, since we're given that Joanne was right. So can anyone tell me what x would be here? Yeah, so x would be 15. And we're given that Joanne gets this right. But the problem says that the teacher says the answer is actually 6 less than what she found. So the right answer is 15 minus 6, which is 9. So now the teacher tells her that she copied the coefficient of x incorrectly, but copied everything else correctly. So what should the coefficient of x have been? So over here, we know this is the equation that Joanne wrote down. And the teacher tells her that she copied the coefficient of x incorrectly. So that means that Joanne wrote down 3 when she was supposed to write down something else. So let's say the value she should have written down is k. Correct coefficient. And we know that everything else that Joanne wrote down was right, except for this 3. So that means Joanne should have written down k times x minus 7 is equal to 38. So this is what Joanne should have written down if she was able to see correctly. So now we have 2 variables here, and obviously we can't solve for both. But what we do know is that the right answer should have been 9. So that means if we put in 9 to this equation, then we can get the value of k. So if we solve this, you get k is equal to 5. So over here, all you had to notice was that the solution to x in the corrected equation would be 9. So when we substitute 9, we can just get our value of k, which is 5. So does anyone have any questions about this one? Okay. So I know this is a little bit simple, but I think we'll definitely get a lot more challenging as the class progresses. So the next problem is actually from the AMC 10, but it's still pretty simple since it was an old AMC 10. So it says that Al gets the disease algebraitis and must take 1 green pill and 1 pink pill each day for 2 weeks. A green pill costs 1 more than a pink pill, and Al's pills cost a total of $546 for the 2 weeks. How much does 1 green pill cost? So first thing, we know L takes one green pill, one green, one pink, every day for 2 weeks. So can anyone tell me how many days are in 2 weeks? Yeah, it would just be 14. So since she takes it every day for 2 weeks, we can just replace the statement with 14 days. So it's easier to understand. Every day for 14 days. A green pill costs one more than a pink pill. So let's say the price of a green pill, price of one green pill is equal to G. Then the price of one pink pill would be one more than that. So price of one pink would just be G plus 1. So here, we know that Al eats one green and one pink pill every day. So if the price of one green pill is G, and the price of one pink pill is G plus 1, then we spend $2G plus $1 every day on Al's pills. So 2G plus 1 on a single day. And we know Al does this for 14 days. So that would mean the total would be 14 times 2G plus 1. But we know that this total cost was 546. So now we have one variable and we could just solve for this. So then 2G plus 1. Actually, I'll let you guys solve. And once you get it, you can let me know what you got. Okay, for the sake of time, I'll just give you guys the answer. But all you'd have to do here is divide both sides by 14, subtract 1, and then divide by 2. And that would give us our value for G. So does anyone have any questions on this problem? Okay, so then we can move on. So now, okay, I skipped this last problem since it's basically the same idea, but you guys can try it out for homework. So now we'll look at challenging one variable equations. So these look scarier than what we had before, but the key idea here is to make a substitution that would help us. So what do I mean? So, for example, in part A, we see that we have a cube root of 2z plus 1 over here. And again, we have cube root of 2z plus 1. And then we have no other variables. So what you do here is you take 2z plus 1 and say that it's equal to y. So then, life is a lot easier. You can just substitute in y and solve. And then if you solve this, you'd get y equals to minus 3, I believe. Yeah. So if you solve this with our substitution, cube root of 2z plus 1 is equal to y, then we get y is equal to minus 3. But we want to solve for z. So then we just substitute the y equals to minus 3 back in. So cube root of 2z plus 1 is equal to minus 3. And then we cube both sides. Cube and cube. So this would be 2z plus 1 is equal to minus 27. And this would give z is equal to minus 14. Yeah, okay, I think you're close. But notice here, we just have to subtract the 1. So I think it's just a silly mistake. But you do 2z is equal to minus 28, and then z is equal to minus 14. But yeah, I think you got the right idea. So yeah. The key idea is just to notice that it looks a lot harder to work with this cube root of 2z plus 1 thing. And the only variable equation we have, or variable term, is cube root of 2z plus 1. So it would make life a lot easier to just lump this into one variable, which is y. And then substitute y back into part A, the equation, and then solve for y. And then you could plug y back in to this equation and solve, which is a lot easier. Okay? So let me erase this. So does anyone have any questions on what we did here? Okay. So part B is basically the same thing, so I won't go over it. But instead this time you say root of r is equal to y, and you solve like that. And then part C, it also isn't very difficult. So I want to end class with a relatively hard problem. So I'll do 3.43 first. So I'll give you guys like 2 minutes to think about it, and then I'll go over it. Okay, so I'll go over this problem now. So over here, notice that our only variable term is cube root of t. And that's the only equation that involves a variable. So let's set cube root of t equal to y. So then we could say root of 3 plus y over root of 3 minus y is equal to 3. So now what we'll do is we'll square both sides. Yeah, probably. I didn't really do it yet. So you square both sides. Since this is a square root, so you can square and you'll get the original value. You get 3 plus y over 3 minus y is equal to 9. And if you solve, this is 3 plus y equals to 27 minus 9y. This would be 24 is equal to 10y. Okay. And this would be y equals to 24 over 10 is equal to 12 over 5. So then we know that the cube root of t equals to 12 over 5. Let me just make sure this is right. Okay, so it looks right to me. I might be wrong though. So we know that the cube root of t is equal to 12 over 5. So then we just cube both sides, or raise it to the third power, and you'll get 12 cubed over 5 cubed is our only possible value of t. So yeah, there's basically nothing special about this problem, except over here you substitute y is equal to the cube root of t, you square both sides, and you solve for y, and then you solve for t. So yeah, I think